Good morning. It's May 7th, and this is your daily brief in science. Here's everything you need to know. A recent study published in the Journal of the National Cancer Institute has revealed significant findings about the role of artificial intelligence in breast cancer detection. The research indicates that AI flagged 76% of mammograms that were initially read as normal but were later linked to interval breast cancer. This study is notable as it is among the first to investigate AI's effectiveness in identifying interval breast cancers within the U.S., differing from European screening practices that employ varied methods and frequencies. The study conducted a retrospective analysis of nearly 185,000 mammograms collected between 2010 and 2019, identifying 148 cases of interval breast cancer. The AI software Transpera was utilized to analyze the initial screening mammograms, scoring them on a scale of 1 to 10 for cancer risk, with scores of 8 or higher flagged as concerning. Dr. Tiffany Yu, the lead author of the study, emphasized that early detection through AI can lead to less aggressive treatments and improved patient outcomes. Radiologists involved in the study reviewed cases of missed detections, categorizing them by reasons such as missed readings in true interval cancers, particularly those with subtle signs that are often difficult to detect. This research highlights the importance of improving screening practices and the potential for enhanced patient outcomes through earlier detection of breast cancer. While AI shows significant promise in this area, it is important to note that it is not infallible and should be used to complement human judgment in radiology. The study received support from several institutions, including the National Institutes of Health and the National Cancer Institute. A remarkable breakthrough in the field of ancient texts has occurred with the identification of a charred scroll from Herculaneum, part of On Vices by the ancient Greek philosopher Philodemus, dating back to the 1st century BC. This marks the first time that a scroll from Herculaneum has provided specific authorial and textual information using non-invasive imaging techniques. Researchers utilized scans from the UK's Diamond Synchrotron facility to detect ink traces on the scroll, revealing its title and author for the first time. The identification was achieved through high-resolution scans and advanced machine learning techniques, earning the team a $60,000 prize from the Vesuvius Challenge, a global initiative launched in 2023 aimed at improving the reading of unopened scrolls. Artificial intelligence has been instrumental in deciphering these fragile, carbonized scrolls, which are among the few surviving texts from the classical era. The first internal images of the scroll were published in February 2025, but deciphering the title page required extensive analysis by papyrologists. Currently, experts are focused on converting the substantial amounts of scan data into coherent text. While the title of the work has been established, the exact placement of this treatise within the larger On Vices series remains uncertain. This ethical treatise offers guidance on cultivating a virtuous life and is recognized in full as On Vices and Their Opposite Virtues and in Whom They Are and About What. Philodemus, a significant figure in the Epicurean tradition, lived from around 110 BCE to 30 BCE, with much of his work found in the Villa of Papyri Library in Herculaneum. Notably, the AI model used for this project was originally designed for analyzing medical images, demonstrating its versatility in deciphering ancient texts. SK Life Science Labs has announced a breakthrough in cancer therapy with the discovery of PVTX 405, a novel IKZF2 molecular glue degrader aimed at enhancing cancer immunotherapy. This research, published in Nature Communications, reveals PVTX 405's potential to improve the immune response against cancer by targeting mechanisms of immune suppression. PVTX 405 works by selectively degrading IKZF2, a protein essential for the maintenance of regulatory T cells, or TREGs. These TREGs play a role in suppressing the immune system and facilitating tumor growth. By reducing the stability of TREGs, PVTX 405 increases the activity of effector T cells that are responsible for fighting tumors, thereby amplifying the overall immune response against cancer. The treatment can be taken orally once daily and has demonstrated significant anti-tumor efficacy in preclinical trials, notably slowing tumor growth. Results indicate that PVTX 405 shows superior potency, selectivity, and safety compared to earlier IKZF2 degraders, which helps to minimize the risk of immune or blood cell-related toxicities. The findings from these trials suggest that PVTX 405 may lead to greater tumor regression and improved survival rates in animal models, highlighting its promise as a cancer therapy. Dr. Ryan Kruger, Chief Scientific Officer of SK Life Science Labs, noted the company's commitment to partnering with biopharma and research institutions to accelerate the clinical development of this innovative immunotherapy. He expressed optimism about PVTX 405's potential to significantly reduce immune suppression, empowering patients' immune systems to combat cancer more effectively. Based in King of Prussia, Pennsylvania, SK Life Science Labs utilizes innovative approaches, including AI-enabled platforms, to develop transformative medicines targeting previously undruggable proteins. As a subsidiary of SK Biopharmaceuticals, the lab focuses on creating treatments for cancer and central nervous system disorders. Researchers from the Hebrew University of Jerusalem and the IDF Medical Corps have made a significant breakthrough in trauma medicine. They have developed a peptide treatment that improves survival rates in cases of hemorrhagic shock, a condition that is a leading cause of preventable death in trauma situations. Led by Dr. Ariel Führer and Dr. Maya Simhoni, this study, published in Scientific Reports, highlights the activation of protein kinase C-epsilon or PKC-epsilon as a key therapeutic approach. This method aims to enhance early survival and physiological stability following severe blood loss. In controlled pig models, the treatment was administered just 5 minutes after inducing hemorrhagic shock. The results were notable, with a survival rate of 73% for treated animals, compared to only 25% for the control group. Treated animals also showed improved cardiovascular stability, which includes better blood pressure, heart rate, and cardiac output, critical factors in managing severe trauma. The analysis indicates that PKC-epsilon activation enhances mitochondrial function in heart tissues, helping maintain energy levels in stressed organs and protecting them from further damage due to blood loss. Current treatments for hypovolemic shock typically involve fluid replacement, which can exacerbate tissue damage. This new approach aims to mitigate those harmful effects. The treatment can be administered intramuscularly, making it practical for medics to use in the field shortly after a traumatic injury occurs. Dr. Führer emphasized the potential of this treatment to transform emergency medicine, improving patient outcomes in both civilian and battlefield scenarios. Future clinical trials in humans are planned to validate the effectiveness of this approach, with ongoing research for additional treatment tools and drugs. This study marks a significant advancement in trauma medicine, with promising results that could revolutionize trauma care. The experimental model closely mimics human scenarios, allowing for prolonged treatment of injured individuals, with animals surviving for up to 7 hours post-injury. Further clinical research is required to validate these findings and facilitate practical implementation of this therapeutic strategy in emergency settings. A recent study from UNSW Sydney and Neuroscience Research Australia reveals a vital connection between emotional processing and chronic pain management. The research, ongoing from March 2023 to September 2024, involved 89 participants suffering from chronic pain, with half receiving an innovative online therapy adapted from dialectical behavior therapy. This online therapy was designed for accessibility, allowing participants from across Australia to engage in group video sessions, use a dedicated app, and follow a self-learning handbook from the comfort of their homes. Participants reported significant improvements, noting a reduction in pain intensity by approximately 10 points on a 100-point scale, alongside enhanced emotional regulation skills. Chronic pain affects around 30% of the global population and is frequently accompanied by mental health challenges like depression and anxiety, complicating effective pain management. Traditional pain medications often fall short, leading to a shift towards psychological therapies that emphasize emotional regulation and resilience in patients. The therapy encourages participants to confront and resolve negative emotions while also acknowledging positive aspects of their lives and setting future goals. Professor Sylvia Gustin highlighted that chronic pain can induce measurable changes in the brain, particularly impacting emotional management due to decreased GABA levels. Dr. Nell Norman-Knott noted the evolving treatment models for chronic pain, emphasizing the integration of psychological and emotional aspects into care. Both researchers assert that improved emotional management may enhance pain experiences and overall quality of life in the long run. Looking ahead, a larger clinical trial is planned for 2026, aiming to include over 300 participants to further investigate the effects of emotional regulation on chronic pain. The findings from the study could significantly transform chronic pain treatment approaches, highlighting the necessity of addressing emotional health alongside physical health. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.